Hi, and welcome to 4.1 Dial Caliper Measurements. In this lesson, students will be able to read the measurements of a dial caliper. As you can see, there's a lot of numbers over here, and numbers over here, and a weird dial thing. So how the heck do you read the measurements? And students will also be able to use the dial caliper in 4 different ways, using an outside measurement, an inside measurement, a step measurement from here to here, and a depth measurement from the end to this part over here. So there's actually 4 different ways to take a measurement with this really cool tool, the dial caliper. Dial calipers are arguably the most common and versatile of all the precision measuring tools used by engineers and manufacturers. As we said, there are 4 different measurements you could take using a dial caliper: an outside diameter or object thickness measurement, an inside diameter or space width measurement, a step distance, and a hole depth. So the first way to take a measurement, and probably the most obvious one, is measuring the outside length. You see, I say it's the most obvious because it's these big teeth over here. That's probably the most predominant thing that you could see, and it's like, oh, I just want to clamp this onto something. And if you do that, then you're taking an outside measurement. Measurements made between the caliper faces shown. So again, between here, and then you read the numbers, and those numbers tell you the distance between those 2 points on the dial caliper, okay? And an example is outside diameter or object thickness. All right, so this is what it looks like if you wanted to know the thickness of this object in this direction here, then you're measuring from this point to this point. All right, that's the outside diameter. Why is it called outside? What does that even mean? Why isn't it just the thickness? Because you could also take an inside measurement. Inside measurements are measurements made between the caliper faces shown here, this line and this line here. So the distance between here and here, okay? Example is the slot or width or hole, and we're gonna do the same thing. You read the numbers the same way, and we'll get to that later. How the heck do you read those numbers? But let me show you what an inside measurement looks like. So if you had a hole and you wanted to know the diameter of that hole, you could use this side and this side. Instead of having to try to put this end in the hole, it's not as precise as being able to put a flat edge up against the hole. Okay? I just wanted to show a comparison. Again, this is measuring the inside diameter, and then you use these larger edges to measure the outside diameter. So the third way to take a measurement with a dial caliper is measuring the stepped length, measurement made between caliper faces shown here. You could actually use this part of it here and this back edge over here. In the diagram on the next slide, it makes it easier to see. So here you're measuring from this position on the dial caliper to this point back here, and you can measure the step length. Because how would you measure how tall this is? It would be hard to use these because you can't clamp on to this, and it would be hard to use these accurately because you could probably get this edge maybe right here, but then where do you put the top edge? You'd have to put a flat piece of something over here to get a measurement. Instead, you use what's called the stepped measurement, and you flip the dial caliper over, and there's actually a way to do that over there. Measuring depth, so measurement made between dial caliper faces shown here. So if you can't put the dial caliper into a hole, you could measure the depth of the hole using those two faces shown, the edge of the bottom of it, and then this whole rod over here kind of slides in and out. So this part will go this way and become longer, and you can get a depth measurement going that way. All right, so this is an example. Again, we're looking at this bottom face here of like the bigger rectangle to this bottom face over here. And this is the part that slides up and down, in and out. Okay. All right, so here's some, before we talk about how to actually read the dial caliper, let's talk about some vocabulary with it. So the blade is the immovable portion of the dial caliper. As I said, this kind of rod structure here does move, but the blade doesn't move. It's like the whole thing. And then this part slides back and forth as well. The slider moves along the blade to adjust the distance between the measuring surfaces. Again, the measuring surfaces are outside, inside, step from here to here, and the fourth measuring surface is the depth from here to here. So you have those four different pairs, and actually the distance between each of those surfaces is the same. So this distance is the same as this distance, is the same as this distance, is the same as this distance. So when you read the measurement, you're actually reading the measurement for all four of those at the same time. But the way you position your dial caliper is how you like take the different types of measurements. All right, so speaking of the blade scales divides each inch into 10 increments. So each increment equals 1/10 of an inch. We're not dealing with your typical ruler with like the half and the quarter inch and eighth of an inch. No, no, no. It's decimal increments. So from here to here is 1 inch, and then you could see the 10 different increments there. It's important to note, look, the numbers are on the left-hand side of the line. So this line is 0. This line is 1. This line is 2. What line is this? What do you think? It's 2.6. The numbers are to the left of the line. 2.6 for this one right here. Where is 3.4? Which line is it? This is 3.4 right there. Okay, so that's how you read it. So it's not just the blade. If it was just the blade, it would be like basically your typical ruler. The cool thing about a dial caliper is it has a dial that allows you to get more precise measurements. So not just like 1.1 inches, you could get 1.123 inches to the thousandths place, which is like very precise, which is cool. That's you want to be able to take precise measurements. The pointer rotates within the dial as the slider moves back and forth along the blade. So this whole portion here slides back and forth, and as it slides, this is like rotating around, which shows that it's a different measurement. The reference edge keeps track of larger increments for like the 1/10 of the place as the slider moves along the rack. This is the reference edge here. It's also known as the index. So this is what we're reading against, this line right here. This will tell us what number it's showing on the blade. So we're looking at the reference edge and reading the numbers, and we're looking at the needle and reading the numbers there. And then we're combining the two into one measurement. Rear tooth rack gear is used to change linear motion to rotary motion. It's the pointer, all right? So it's just a way to slide the dial caliper back and forth without messing up the gears. It's you want to use like your thumb to move the slider back and forth. Accurate dial caliper reading requires several steps. The important step is to zero the dial caliper first before taking the measurement, because this dial is made to rotate around. So if it's completely closed like this, that should read out 0, but it's actually reading a little bit more than 0. So what you would do would follow these steps. It says before measuring, zero the caliper. Close the caliper completely, as you can see. Then you're going to loosen the dial lock, and then you rotate this whole face. The whole thing rotates. See how the zero is kind of like this, and now the zero is straight up and it's aligned with the needle. The needle doesn't actually move. You're rotating the entire face so that the zero is aligned with the needle. So you rotate the dial to read 0, and then you tighten the dial lock to lock it in place there. Each time the pointer completes one rotation within the dial, the reference edge of the slider moves the distance of one blade scale increment, or 0.1 inches. So basically, if you go around once, that means you went 0.1 inches, okay? One revolution of the pointer within the dial represents 1/10 of an inch. The dial is divided 100 times, therefore each graduation equals 1/1000th of an inch, which is really cool. You could take some precise measurements with that. So here are the multiple steps. This is the example I'll give, and then you're going to do 2 examples on your own. All right, it says to determine the outside diameter of this pipe section, first identify how many inches are being shown on the blade scale. Well, first of all, is this an outside, inside, step, or depth measurement? We could tell it is a outside measurement because they're using those 2 faces to take the measurement. All right, so how many inches are being shown? The reference edge is located between the 1 and 2 inch marks. So here is 0 inches, this is the 1 inch, and we can't see the 2 inch yet, so it's between the 1 and the 2 inch, and this is the reference edge. So we know we have at least 1 inch. We have 1 inch and a little bit. All right, so record each significant digit. So far we just know it's 1 inch. Identify the 0.1 inch increments marks shown to the right of the last inch mark. So we have 1, and then we have 1, 2, 3, 4. I see 4. I see the number 5, but are we at the line? Is the reference edge at that line for 5? Shouldn't the line be right over there for the 5? I don't think we're really there yet. We're not at the 5 yet. Remember how I said that the numbers are to the left of the line? So far we only have 1.123, and then there's that little bit between 1.4 and 1.5. We want to know how much further did we go. So far, all right, 0.4, 1.4. And if it was just a regular old ruler, that's basically all we could get. With accuracy or being precise is 1.4. But since we have this nice dial, we could get a couple more decimal points in. So then you're going to identify the pointer increment mark shown on the dial, and you just read out like you're reading a clock. So this is at the 37-inch mark, the 0.037 inch mark. So you take that 37 and you just tack it on to the end of what you already read out, 1.4. So it's 1.437. And you could even make an estimation. So it's definitely at the 30, 1, 2, 3, 4, 5, 6. It's definitely at the 37 mark, but you can make an estimation. It's a little bit past that. So we can estimate 0.0001 inch. That's powerful. Wow. Look at that. Look how precise that is. Okay. You're going to add values together for the dial caliper measurement to get your final answer, 1.437 with certainty, and then we're estimating this last 10,000th of an inch because it was a little bit past that 37 mark. All right, so that's how you do it. First you read the blade, then you read the dial, and if you want to be fancy, you can even estimate a little bit after that. All right, so how wide is the block? Let's practice this one, okay? And they zoomed it in for you. So this is what the measurement is there. So this is your first practice here. Pause the video here and take a look. All right, so did you say it's at the 1 inch mark? Hopefully you said it's at the 1 inch mark. What's the next one? 1.4. We are definitely past the line. The reference edge is past that 4 line, but just a little bit past it, right? It's actually at the, it's just 0.002 inches past that line. And you could read, this is 1, 2, 0, 2. Did we trick you with the 0? You have to put that 0 there because it's not at the 20. If you put the 2 at this point here, you're saying, oh, it's at the 20 mark. No, it's at the 0.2 mark. Okay. And then if you wanted to, you could estimate. They estimated to, they said it's like 0.0002 inches past that. You're just basically saying, like, if the needle was right in the middle, you would put a 5 at the end. They're saying it's like a 2. Okay. So you should have gotten 1.402, definitely, and then your estimate could have been around there. So 1.4022. All right, pause the video here and do another practice. Pause it. I'm serious. Take a look. What do you think? Well, I'm looking at my reference edge, which is right here, okay? And I know I'm past the 3 mark, so I'm at least 3 inches. And I'm past this is for the 7, so 3.7. And now I'm ready to look at the dial. Okay, so we have 20. That's at least 20. 20 something. 20 what? 21, 2, 3, 4, 5, 6. All right, so I know that, and it's a little bit past that, isn't it? Maybe 1 or 2, I don't know, something like that. Inches, okay? As long as you had this chunk of it, you're good. And then I estimated this at the end because this needle is a little bit past that line, so I just estimated a 0.0002 inches tacked onto the end of it. Hopefully you got that. You get one more shot. All right, pause the video here. Think about it. What do you think? All right, did you pause the video? Because I'm going to give away. This is something that people get tripped up on a lot. So if you didn't pause the video and try it on your own first, because I'm going to try to trick you here. And if I trick you now, you won't get tricked on the test. You'll learn it. But if I show you the trick without you trying it first, you're not going to remember it as much. I want to really, really try to trick you here so that you remember it. All right, hopefully you paused it. Did you pause it? Pause it. Come on. All right, now you paused it and you tried it, and hopefully I trick you. Let's see. So this looks like a 2 to me, even though the picture is very grainy. That's a 2 inches, 2 point, and this is the trick now, okay? I see a 3 over here. Did you put a 3 there? Wrong. You're wrong. That's okay though. That's something that people always do. Mr. Nangle, I see a 3 over there. Yes, but you don't see the line. The reference edge is not at the line for the 3 yet. Okay, you're almost there. As noted by the dial, we're almost to the next 10th of an inch. We're almost here, right? You can see this distance corresponds with this distance here. That's a cool way to think of it. All right, so yeah, we're not at the 3 yet. We're less than 3. So what is less than 3? 2. And we can tell it should be 2 because that's the only line that we see right there. All right, so this is the line for the 2. We cleared that, so we have at least that, but we're not at the line for the 3 yet. And that's the trick. And it's okay if you got tricked up on that first. I was trying to trick you on purpose. Just because you see the number doesn't mean you're there yet. And the reason they do it like that is because if it was on the other side, you wouldn't, if it was like here instead, and you were at the 3, then the index would be covering up the number and it would be even more confusing. So they tried to make it so that it's less confusing for you, but it ends up tricking people. All right, so we have 2.2. That's nice. Now we're ready to look at the dial caliper. As soon as you know the tenths place, then you move on to the dial caliper and you read out what the number says. So I'm looking at 80 something. I immediately put an 8 there. 80, okay, this is the 1, this is the 2. It looks like it might be at the 3. Maybe it's a little bit before. If you said 2.2830, I'll give it to you. If I'm being honest with myself, I don't know. Maybe it looks like it should be a little bit before. It looks like it might be right on there. But you might have also said 81, 82, and almost 83. So you're estimating that way, which is a possibility as well. All right, either one of those answers is acceptable because you're just estimating, right? Beautiful. Very nice. Inches, don't forget your units. Okay, that's about it. Thanks for watching and have a great day.